I have a presentation, and as it's getting set up, let me first thank you very much for that fascinating introduction into the issues, and to thank all of the young leaders who have taken home certificates for their involvement in big data. In many respects, we are at a new point in technology and in business. We've heard this before because it's true. We've been there before. You could imagine that in the 1960s, if you asked, well, where is computers going to go? A person who was at the forefront of computing would not know how to answer the question. And you'd say, well, you have to understand that by 2013, computers will touch every aspect of society. So to ask where's computing going to go, even though it would fill a room this big as a mainframe, wasn't quite right. It's going to go everywhere. And likewise, if you think about the internet around 1992, if you said, well, how's the internet going to change things? Where is it going to go? Where will you find the internet? Where will it develop? What you'd find is the person again would be nonplussed and would say, well, by 2013, it's going to be hard to find any part of human society that's not going to be touched through computer networking. Right? Well, so too with big data, so too with the new uses of information, big data just being a very good term to use to explain what's happening. In 20 years, all aspects of society are going to be based on taking information and learning from it. Let me explain what I mean with a story. Think of the story of what happens today when you go to a doctor. The doctor is going to take an X-ray and try to determine if you're ill or not, and the doctor is going to look at the X-ray. And the doctor may have 20 different ideas in his or her mind in terms of what the diagnosis should be. What's the telltale sign for cancer, for example, if that's what you're looking for. And maybe after about 30 years of practice, seeing lots of cases, seeing lots of rare cases, seeing rare cases in which the diagnosis has been wrong, and seeing cases in which the diagnosis has been right and you only found out afterwards, right? That in fact, you now actually have maybe 30 heuristics, 35, of which maybe 5 or 10 are so latent, the doctor can't even articulate it, right? It's just sort of a sixth sense that the person has in his or her 60s that he or she didn't have in the 20s and 30s. Okay, but there's always going to be rare cases. First time it comes up, it's rare. Person dies. Second time, doctor treats it, recognizes it as a rare case. Treatment was ineffective, but the patient lives anyway, so the doctor thinks it was effective, right? Third time, who knows? Fourth time, still don't know, still a rare case. Think about what it's going to look like in the future. If we gave all of our medical information, every single individual, all throughout Europe, spanning, say, 3 decades, in terms of what the problem was, say the X-ray, what the outcome that we found out, in fact, it was, whether it was cancerous or not, the computer could actually infer the telltale signs of cancer itself and could make a diagnosis that perhaps would be as good and probably better than the doctor's. What is certain is that the computer might find telltale signs of cancer that we ourselves didn't know to look. Why should we stop at 35? Maybe there's 36, maybe there's 45. But again, we don't see it. The idea of a rare case still exists. It's uncommon, but now it's enshrined in the data and in our database in the same way that tidal maps can help a sailor go to places where they've never been to because it's on the map, because other sailors have been there before. So if you will, the doctor of the future is going to be the database. We are going to rely on information to help us make decisions in this one domain of healthcare, similar to how we would never allow an airline pilot to dare land a plane, a jumbo jet, without its computer instrumentation. Just as we rely on it in that domain, so too for many facets of society, not just medicine, we're going to be looking at the data, listening to it, and making decisions based on it. What is big data? Let's not try to get hung up on a definition. And the reason why is that if we tried to define the web, say in 1994, we would have one decision. If we tried to do it in 2007, we would have had another. But what's certain that if we were to try to describe what the web is in 2007, we probably wouldn't have mentioned Facebook or Twitter. And today, these two services look like the very infrastructure of the internet. Big data, however, is something new. And if we were to kind of look at the qualities, what we can say about it is this. There is a value in a large body of data that is missing, that we cannot extract when we only have smaller amounts. Now, our other panelists can talk to some of that, particularly Alfred Spector of Google, because one domain that's very promising, and the one that I've described without actually using the technical language, is called machine learning. And the underlying principle, if you will, of machine learning, why it's been effective and why it's effective now, is that we're able to apply not just a little bit of data, but a lot of data to the problems. And when we have more data, we get better outcomes. Although what I described in terms of the X-ray is actually a thought experiment. It's based on real research that happened in Stanford about 2 years ago, in which the computer was actually very good at identifying cancerous cells in biopsies. But here's the nub. Human technicians looked for about 12 different signals to whether a cell was cancerous or not. The computer found about 15. It spotted telltale signs of cancer that human beings never knew to look for. Specifically, it was not looking at the cells themselves. It was looking at the distance between cells in cellular material called stroma. We never thought of that. So that's what's to play for. That's what's actually happening. As other speakers have said, the amount of information is growing very quickly. About 2 or 3 years, it doubles. This is from 2007, and the bottom portion is digital. The top portion is analog. So if you were to actually think of where it was in 2010, it would have been twice as big. The small beige band on top would be half as big. The green part would be going towards the floor. And now let's double that again. And so we're now at maybe a 3-story building in terms of the amount of information in the world. Actually, no, not quite as long as that, but it's certainly up until a couple more meters high. The story of Faircast is a very interesting example of how we can reuse information in new ways. A person was on an airplane and was upset that other people paid less, even though they bought the ticket sooner. So what he realized is he didn't need to know how airlines price their airfares. All he needed to do was to take all of the known airfares for every single given route and every seat on the flight, and the distance between when the flight was taking off and when they bought the ticket. It would empower customers to know whether a price they're seeing is likely to go up or likely to go down. Should you buy the ticket right away, or should you wait? He called the research project Hamlet. To buy or not to buy? That is the question. A few years later, by 2007, he was crunching 200 billion price flight records to make his predictions, representing almost every single flight in all of American civil aviation. Microsoft knocked on his door around then, bought the company called Faircast for $100 million. And you absolutely know that when the airline reservation system was built in the 1960s, the airlines themselves never imagined that this information would ever be used to undercut their business model. But that's what had happened. Data, if you will, is a raw material. It is a resource. It is a vital economic input. Now, one reason we have so much information around in the world is because we're datafying things that had never been rendered into data form before. It was always informational, but never actually in the form of data, that we could process it, that we could use it. So let's use the term datification for this. Think about the way you're sitting right now. Everyone is sitting slightly differently, right? The commissioner, the minister, right? The young leaders. If I was to put 100 sensors under your chair right now, I could create an index for who you are that's almost like a fingerprint that's fairly unique to you. It's based on your weight, the distribution of your weight, your posture, your leg length. What's the application here? Well, researchers in Tokyo are doing this to put in car seats, anti-theft device. Suddenly, the car would know whether the approved driver is in the car, and if not, it would conk out. Maybe you'd have to enter a password to continue driving. If you have a teenager at home, you can imagine a very practical application of this technology. You say you're not allowed to take the car out after 10 p.m., and like Cinderella's chariot, it turns into a pumpkin. Okay, what if every single car in Europe had this instrumented in the car seats? Maybe we'd be able to identify the telltale signs 30 seconds prior to an accident, the shifts in body posture that predicted that a car would get into an accident 30 seconds before the crash. Maybe we would have datified driver fatigue, and that when we see someone slumping in that position, the car would know to send an internal alert, vibrate the steering wheel, or send a chime saying, wake up, pay more attention. Those are the sorts of things that we can do when we datify aspects of society. We're able to share, store, process, and use the information and extract new value from it. So Facebook datifies our friendships. Twitter, our stray thoughts and our whispers. LinkedIn, our professional contacts. All aspects of society are going to be benefiting from big data. Just think of education today. Right now, a teacher might grade an exam, and you'll have some students who get in the 70s, some in the 80s, and some in the 90s. What one interesting professor did at Stanford was when he looked at the test scores, he realized that in one of these massively open online courses, that a huge percentage of his students, turned out to be thousands of his students, had gotten an answer wrong. Teachers always knew that. They got the answer wrong with the exact same answer. When he kind of studied it a little bit more, he realized what was happening is that they were inverting an algebraic equation, thinking that the sequence didn't matter, but it did. So what he learned was that he needed to actually teach the course material a little bit differently and a little bit better. But it also helped the students, because now it doesn't say you got the answer wrong. When you upload your homework, a little alarm box goes off and says, hey, wait a minute, take a look at your math, check it. You might want to think about something differently. So in some ways, students are benefiting because they're able to learn from the data, but also there's a feedback loop that's actually helping pedagogy, helping the professor learn as well. Textbooks in the past have been one way. You received information. In the future, they will talk back to you by telling you what you need to practice at, what you need to be better at. So it's a whole new world, and it's one that we're building ourselves, and it's going to be a lot of fun. I have to admit that I have a book out, but that's not the point I wanted to tell you. One of these books you're going to see is Chinese. This is going back to what the minister has said and about what's to play for in Europe. I've sold 100,000 copies of the book in China, and it's been on the bestseller list at #1 for business books. I'm not boasting here. I'm basically warning you. I'm threatening you. China sees this as a way with which they can capitalize at the right moment in technology in ways that they never could before. They were a follower in computing, and they had to buy computers from the West. They were an adopter of it. When the internet came around, they were still a developing country. They had to take in business models and technologies from the West. They don't want to do this. They see this as part of their national mission for national progress. They are rallying around big data because they see that the time is now. America and Europe are on bended knee and too busy fighting other fires that they have, and that they are now not a weak country but a strong one, and they are going to take big data and run with it, and this is going to be the area where they are going to be the leaders, and that the world will be essentially following the weather patterns set in the Middle Kingdom. And why not? That sounds great. I mean, it's a glorious thing for everyone and all of humanity that we're at a stage now that we can actually take data and learn from it to create new forms of economic value. So there's a lot to play for, and there's going to be lots of winners and losers, and I look forward to being a part of it. Thanks a lot.